Hello, adventurers. Welcome back to the floor on stacks. In our last video, we wrote our stack class. We had 4 bodies: push, pop, size, and empty. And our self-test on our stack lit up all green. The top method was already provided for you. Today, we're going to use that stack for the first time on a classic problem. Do the brackets in a string balance? So today, we're going to edit in one function in one file. We're going to go to the hero/lint.cpp file, which has the body of the isBalanced function that takes a const string reference and is going to use a stack of type char. Okay. So main.cpp's lint text command is already wired to call it. Right now it prints not balanced for everything because the stub returns false unconditionally. After today, it returns real answers. So nothing else changes. Our stack header file from the first video stays as is. You just need to make sure to include it, but it should already be included at the top of our lint.cpp file here. So let's go ahead and just show you right now that this command does not work as it's supposed to. So let's say I want to lint, and let's say I said, okay, I want to lint, and let's say checking out my parentheses and brackets, I did A, B, C. So you see I have parentheses wrapping this statement. I then have A in curly braces, B in parentheses, and C in square brackets. I can run that, and you see it says it's not balanced right now. I could also do something that for sure is not balanced, and you see it says that too. So the lint command is wired up and running right now, but it's broken in the laziest possible way. It says not balanced to everything. The first string is perfectly balanced, and it still says no. So that's the stub. Is balanced right now just returns false. But today we're going to make it actually look at the string. And the tool it needs is actually what you built in the last video. It needs a stack. This is the first real thing almost any programmer ever does with a stack. And it's the thing the compiler did to the very file you're typing in to check your braces. So let's go ahead and let's open up our hero lint.cpp file here. We'll close these two out. Go to hero. Move this down a little bit. Lint.cpp. Okay. Perfect. So one thing to think about, just the algorithm here. Before we write code, let's actually think about the algorithm, okay? So every time or every opener we push, every closer we check, the top of the stack, does it match? If yes, pop and move on. If no, or if the stack is empty when a closer arrives, the string is broken. So then we stop, okay? So let me go ahead. I'm going to pull up a little notepad, and we're going to walk through this here. Okay, so let's walk this with me. Let's say we did an open parenthesis, right, like this. So then we push it. So the stack then has a parenthesis. Then we could say open brace, which would be our little curly brace. We push it. The stack then has a parenthesis and a curly brace. I then say, okay. We then have our A character in that first line we did. And this was going back to that first lint command I did. So we had A, but A is not a bracket, so we ignore it. We then have close brace. We, of course, had our right curly brace in that case. So we say the top is a left curly brace, so we match it, and then we pop. Okay. So then at that point, the stack is just our parenthesis. And then we say, okay. We then have a space, so we ignore that. And then we say, okay, we have an open parenthesis, right? We push. Therefore, the stack is now 2 parentheses. Okay. Then we have a B, so we ignore that. We then have a close parenthesis, right? Our top is a parenthesis. We have a match, therefore we pop. Therefore, the stack at that at that point is, again, just one open parenthesis. We have a space, so we ignore. We then have an open bracket, right, which is our left bracket there. We push it. The stack is now a parenthesis and a left bracket. We have a C character, so we ignore it. We then have a close bracket. Should be our close there. We say our top right now is a left bracket. We have a match. Therefore, we pop. Therefore, the stack is then just an open parenthesis. We then have a closed parenthesis. As such, we go over our top right now is a left parenthesis. So we have a match. Therefore, we pop. Therefore, the stack at that point is empty. Okay. Whew, that was a lot, but there it is broken out for us. So the end of the string, the stack is empty. It's balanced. The rule is balanced exactly when every closer match the most recent unmatched opener and nothing is left waiting at the end. Most recent unmatched opener, that phrase is why this is a stack and not a counter. Okay. So now we could talk about a counter example. Okay. So let's move down here. So let's say we had where we did our parenthesis, curly brace, close parenthesis, and then a curly brace like that. So we would say, okay, maybe we have an open parenthesis push on the stack. So the stack will be open parenthesis. So say we're doing this right here. So we start off, let me make this down so it'll be a little easier to understand. So we say we open parenthesis, we push it. So our stack then is just an open parenthesis. We then have an open brace like this. We'll push it. So then the stack is going to be as such. And then we can say now we close parenthesis as such. Okay. But here the top of the stack is actually this, right? But obviously the close parenthesis wants to close with a open parenthesis, right? So we have a mismatch on the first closer. So we return a false right then and there, okay? A program, if we had a program that just counted brackets, so it'd be like two openers, two closers in this case, that it would call this balanced, okay? But it isn't, right? We know that. The order matters here, okay? Only a stack remembers the order, okay? So perfect. So hopefully this kind of shows you the difference between the stack way of doing it versus just if you were trying to just count up your characters there, okay? So let's now go ahead and let's find our isBalanced stub here. Okay. So you see right now we need to replace this right here. We have a const string, standard string. Right now we just have the input, but the input's going to be called input is what I'm going to call it. Okay, and then when we're in here, we need to first of all guess a stack of type char, and we'll call it S. We'll say for char C. With our input there, we're going to go through and loop here. Okay, I'm going to say switch C. And we'll then open us up. We're going to do this little switch statement. So I'm going to say case. We have a open parenthesis. We'll say case. I'd rather it be right here. Well, it's not going to. Let's see. There we go. Case. We'll do open bracket. I'll say case. Open curly brace. I'll say s.push C. All right, so if it's one of these things right here, I want to push it. Then we can break. Otherwise, if we have a case with, for example, a closing brace, we could say, okay, if s.empty, or s.top is not equal to a open parenthesis, we could return false in that case. Otherwise, we could say s.pop. We could say break. We could say case. If it's a closing bracket, we could say if s.empty or s.top is not equal to the opening bracket. In this case, sorry, just tab down there. Not equal to the opening bracket. Okay, I could return false. Otherwise, we say s.pop, break. Oh, need the parentheses right there. There we go. And I say case. This would be the closing curly brace, should be on that now. We'll say, okay, if s.empty, if I could type, s.empty or s.top is not equal to the opening curly brace, then we will return false. Otherwise, we'll say s.pop, and I'll say break. Okay, perfect. And then I can say default, and this is basically my ignore non-bracket characters. I can just say break. And now I should have two closing braces right here. And then outside the loop, I'll return s.empty. Right? Is this balanced or not? Are we left with an empty stack at the end? Okay. So, once again, let's kind of go through and walk through this. So, we have a stack of type char. That's from the first video. So, it's instantiated here at the very beginning. So, we're going to walk every character. The three openers here, parenthesis, bracket, brace, all do the same thing. We push the character. That's why they stack up with no break between the case labels until the shared push. Each closer is the interacting part, and they're all the same shape. Take close parenthesis. There's two ways it can fail, and we check both in one line before we touch the stack. If the stack is empty, there's no opener waiting. A closer with nothing to close, so we return false. Or if the top is not the matching open parenthesis, it's a mismatch, like that second example we did in Notepad a second ago. That would return false. Only if neither failure fires do we pop the matched opener and move on. Bracket and brace are the identical pattern there with the open square bracket and open curly brace. Our default there is going to say, okay, well, for anything that isn't a bracket, so letters, digits, spaces, we ignore. The lint here is checking the structure, not the content. And the last line is the thing that beginners oftentimes forget. We need to return s.empty. We are not balanced just because we survived the loop. We're balanced only if nothing is left on the stack. So if we had just three open parentheses, it would survive the loop, of course, but it's still wrong. It's three openers, but they were never closed. So that final empty check is what catches openers that were never answered for us in this case. So let's save this and let's build this here. Perfect. So we can say, okay, Joe. We can say lint. We can say, let's try our A, B, C example. Balanced. Lint. Three open parentheses, not balanced. Lint. Let's do the thing we did a second ago. The parenthesis, curly brace, close parenthesis, close curly brace. Not balanced. We lint hello world. Is that right? Not balanced. Okay. So the same first string that the stub rejected now reads balanced because we actually walked it. The second one, though, is not balanced. It caught on the first closer exactly like when we were walking through it in Notepad. And hello world there is not balanced for the other failure mode. It reaches the end of the string with that open parenthesis still sitting on the stack unanswered. So the final s.empty call actually, the check returns false. So two different ways to be unbalanced here. We have mismatch mid-string or leftover at the end, and our function catches both. So let's step back for a moment before we end today and just notice what happened here. We used a data structure we built ourselves to solve a real problem in about 15 lines. The compiler reading our C++ code does the same thing with a much bigger stack. To know that every brace you open, you close. That you've written a very small version of a piece of every compiler, linter, and editor on the earth, which is pretty cool. So hopefully this was helpful. And in the next video, we're going to talk about undo and recursion itself as an explicit stack. And then we're going to talk about the hollow echo. What happens when we call top on a stack that's empty? So I will see you there, and I hope you have a great rest of your day. Talk to you soon. Bye-bye.